It's a Tuesday morning in the year 2060. A woman walks out of her apartment into a city that sounds different. There are no engines idling at traffic lights, no smell of gasoline, no haze hanging above the skyline. The air is just clean. On her way to work, she passes an old gas station, not an operating one, a museum. A group of school children gathers around an ancient fuel pump as their guide explains that, for more than a century, people filled metal tanks with flammable liquid and ignited thousands of tiny explosions every minute just to move from one place to another. The children laugh. To them, it sounds as strange as powering a smartphone with coal. Meanwhile, thousands of miles away, a cargo ship crosses the Pacific Ocean using fuel made from renewable power. In Texas, an abandoned oil platform has turned into a tourist attraction. In Saudi Arabia, a country that once defined the oil age has spent years investing in industries that barely existed at the beginning of the century. This future isn't guaranteed, but if today's technological, economic, and geopolitical trends continue, it is growing far more plausible. The Age of Fire, the era that powered civilization by igniting fuel, is slowly giving way to something entirely different. And the reason may surprise you. It's not because the globe is running out of oil. It's because we're discovering better ways to use power. For hundreds of thousands of years, nearly every major breakthrough in human history depended on one thing: fire. We consumed wood to cook food. We ignited charcoal to forge iron. Coal powered factories. Oil fueled cars, airplanes, and global trade. Natural gas heated homes and generated power. Different fuels, but the same basic idea. Stored power released through combustion. That fundamental process built cities, connected continents, and transformed humanity. Without it, the modern era wouldn't exist. But every technology eventually meets something better, and combustion has one enormous weakness. Most of the power it creates is wasted. A typical gasoline engine converts only about 20 to 30% of its fuel into movement. The rest disappears as heat, vibration, and noise. Electric motors routinely exceed 90% efficiency. That difference isn't political. It isn't ideological. It's physics. For generations, fossil fuels appeared remarkably cheap, but the price displayed at the pump never reflected the full cost. Air pollution, healthcare expenses, climate damage, military spending to secure supplies. These costs were just paid somewhere else. As governments, businesses, and insurers increasingly account for those expenses, the economic advantage of fossil fuels grows less obvious. Yet environmental concerns alone didn't trigger today's transition. Technology did. Few technologies have grown cheaper as quickly as solar power. In the late 1970s, generating a single watt of solar power cost around $77. Today, that same watt can cost well under 30 cents in many markets. That's one of the steepest cost declines ever recorded for an energy technology. Unlike oil, whose price depends on extracting finite resources, solar panels grow cheaper as manufacturers learn to build them faster, better, and at larger scales. Economists call this a learning curve. The more we build, the cheaper they get. Wind power followed a similar path. Today, in many parts of the globe, building new renewable power plants costs less than operating some existing coal plants. The transition didn't occur because people suddenly grew more environmentally conscious. It unfolded because the numbers began to favor cleaner technology. For years, critics raised one question: what do we do when the sun goes down? It was a fair criticism. Then batteries evolved. Lithium-ion battery prices have fallen by roughly 90% since 2010, while their capacity has steadily grown. That single trend reshaped multiple industries at once. EVs proved practical. Home power storage grew affordable. Grids gained new ways to balance supply and demand. Instead of wasting excess solar power during the day, it could be stored and used after sunset. A problem once considered nearly impossible proved highly manageable. Cars were only the beginning. Electric transit now operates in cities around the globe. Heat pumps can warm homes using far less power than traditional furnaces. Factories are experimenting with electrified steelmaking. Some industries are replacing coal with hydrogen produced using renewable power. Every sector that can switch to the grid gains the same advantages: fewer moving parts, higher efficiency, lower maintenance, often lower lifetime costs. Current isn't replacing combustion because it's fashionable. It's replacing it because, in many situations, it's the better machine. Not everything can be electrified easily. Commercial aviation demands extremely high power density. Ocean shipping moves enormous loads across vast distances. Heavy industries like cement and chemicals remain difficult to decarbonize. These sectors may rely on a combination of sustainable aviation fuels, green hydrogen, ammonia, methanol, and other synthetic fuels produced using renewable power. The exact solution is still uncertain, but the direction is growing clearer. Even many future fuels may ultimately begin with clean electrons. For a long time, nuclear fusion was known as the technology that always seemed just out of reach. Today, that picture is beginning to change. Private companies and government laboratories have made significant technical progress, and several hope to demonstrate commercial systems during the 2030s. Whether those timelines prove realistic remains to be seen. If fusion succeeds economically, it could provide abundant low-carbon power. If it doesn't, the broader shift toward electrification is still likely to continue because today's renewable technologies are already proving highly competitive. In other words, fusion could accelerate the transition, but it isn't the only path forward. For more than a century, global power often followed oil. Countries with large fossil fuel reserves held enormous influence. That balance is beginning to evolve. Future energy leadership may depend less on oil fields and more on manufacturing capacity, power grids, critical minerals, software, and engineering. Nations rich in sunlight, wind, or industrial expertise may gain new strategic advantages. Even traditional oil producers are investing heavily in preparing for that possibility. History is full of technologies that grew obsolete faster than anyone expected. Whale oil, steam locomotives, film cameras, landline telephones. Their decline wasn't gradual forever. Eventually, adoption reached a tipping point. The same could occur with fossil fuel infrastructure. Oil wells, pipelines, refineries, and gas stations could turn into stranded assets if cleaner alternatives continue growing cheaper. Markets often move slowly, until suddenly they don't. The energy transition will not be easy. Electrical grids need expansion. Mining must grow more sustainable. Long-duration energy storage remains a major challenge. Some industries still lack perfect alternatives. These are real obstacles, not reasons to dismiss the transition, but reminders that large technological shifts rarely unfold overnight. History suggests they arrive gradually, then much faster than expected. Over the next 10 years, EVs are expected to grow even more competitive, while renewable power paired with storage is likely to dominate many new power projects. During the following years, breakthroughs in industrial processes, aviation fuels, and energy storage could reshape sectors that remain difficult to decarbonize today. By the middle of the century, fossil fuels may occupy a much smaller role than they do now, perhaps similar to the niche position that whale oil holds today. Exactly how quickly this unfolds remains uncertain. The direction, however, is crystallizing. Imagine cities that are quieter, cleaner air, more stable power prices, greater energy independence, less dependence on volatile fuel markets. Not a perfect society, but a different one. A society where power comes mostly from machines that harvest sunlight instead of fuels that ignite beneath it. Human civilization wasn't built because we discovered fire. It was built because we kept improving the tools that harnessed power. Fire powered the first great chapter of our story. Clean current may power the next. The end of gasoline, if it comes, won't arrive with a dramatic announcement. It will unfold the way most revolutions do, one better machine at a time. And one day, a child may stand in front of an old gas pump, smile in disbelief, and wonder how an entire civilization once depended on igniting liquid just to get to work. If you enjoyed this video, please give it a like, subscribe to the channel, and hit the notification bell. Your support helps us create more documentaries like this. Thanks for watching, and we'll see you in the next one.